Good afternoon, everyone. Welcome to APNIC eLearning web class. Today is Wednesday, the 18th of January in 2017. It's 3 o'clock in the afternoon from Brisbane in Australia, where I'm conducting this class. And the topic that we're going to discuss today is about network security. So particularly, we will look at some beginner topics, fundamental aspects that are necessary for us, going forwards if we want to dive more into the security field, security aspects and things like that. Now, just a little bit about myself before we begin that. My name is Sheryl Hermoso. I work as a training officer for APNIC. So hopefully most of you know who APNIC is. APNIC is the Asia Pacific Network Information Center. We are the Internet Registry for the Asia Pacific region. Now, our training team conducts different workshops, either face-to-face or online like this, on topics that are related to the Internet. So we have routing, BGP, MPLS, network security, DNS and DNSSEC, Internet resource management, and a few others that are related to this. So for this e-learning session, we will have this for about an hour. And at the end, I will be asking you to fill in a short survey. So the link will be posted and it's part of the slides here. You'll see that towards the end. And I would encourage you to please fill that in because that is very important to us to know whether, we've achieved our goal of extending, the knowledge on network security to all of you. Now, I would like this class to be as interactive as possible. So if you have any questions at any time, please feel free to write them down on the chat. So the way that you can interact with me is only using the chat. If you raise your hand, normally that means I will be transferring the audio to you. So I normally decline that. So if you can raise your hand, but also type in the question on the chat panel. Okay, no audio or video is allowed from the participants. Okay, now that out of the way, I would like to get started with our topic. As I've said, we will be focusing on Internet or network security fundamentals. And as part of this course, we will be looking at particularly information security in the 3 different goals. CIA, do you know what that means? And do you know what it stands for? We will also look at attacks. Okay, so obviously the best way to look at these types of attacks, we will only have a few examples for you, but we will look at them from a layered perspective. Okay, what types of attacks, what are the weaknesses that are exploited on these different layers, and how are they done? Okay, how are they executed? We will look at those types of attacks. We will look at the security side of things. Now, once we know what are the possible issues and weaknesses happening to each layer, how are we protecting them? Okay, what are the different methodologies, different protocols, or practices and techniques that is being used by the internet or the security community with regards to this. Particularly, we will be looking at trusted networks, use of access controls or ACLs, crypto, public key infrastructure, okay, VPN and IPsec. And the last part there is a service that is being offered by all the RIRs, such as APNIC, which is the host database, which you can also use for troubleshooting and for maybe if you're having some security issues and for protection of your objects, it can also be used. So we will discuss that later. Hopefully, we'll have enough time to cover all of these. So why are we talking about security? Okay, as we all know, the internet has been around for quite a while now. Okay, I don't have to go through the details or the history of the internet, but the one thing that we all know is the internet is there because it achieves a purpose, which is connecting people, connecting devices, and exchanging data, okay, or sharing resources with each other. That is the main goal of a network or the internet as it became like bigger and bigger. But security was only a secondary thing. At first, it's mostly a trusted system. Everyone knows everyone else. Everyone knows which computers or which mainframes or which devices are connected to the network. Nowadays, you can't say that, you trust everyone that you're connecting to, right? The internet has become such a hostile place because there are many good things that you can get out of there. There are also many bad folks that are operating on the internet, okay, with bad intentions for you. However, you have fundamental aspects of your information, of your business as well, that you want to be protected. such as information about yourself, to protect it from, of course, maybe someone wants to steal your identity, so identity theft. You can also, you also want to protect your business models, okay, everything information about your business, okay, about your employees and things like that. So basically, there are important information that you want to keep confidential and a secret from everyone else. And so we cannot, of course, disconnect ourselves to the internet, because most of the businesses, most of the transactions that we're doing are all on the internet nowadays. So the main thing that you want to do is, of course, provide some maybe walls or protection on your system. Now, the way that you look at security has changed over time. In the beginning, it's all about LAN connectivity. So it's mostly local. Okay, how do you share data? You put up into a shared folder, or you share the device or the printer and things like that. So the concept of sharing it to the internet, okay, is not quite as much. Normally, you access the internet to get information, mostly to browse browse the websites, yeah? But for sharing of your data, it's mostly just within the local network. So you can say that most of the people there are already trusted. If you're sharing company information, you don't have to provide any extra protection to it. Maybe a little bit, but not so much. However, as things change, later on we've become more online centric. Okay, there has become what they call it, the Internet 2.0, where you have applications where you can access information via your mobile devices, right? So it becomes easier. If you have a personal device, okay, you might open information that is, usually just open using a company computer. Now you use your personal devices to access them. So it's become wider. The scope now is no longer limited to the maybe computers that are issued by the company, right? So you need more protection to that. Another thing is it now evolved into more cloud-centric setup. What do we mean? Before, we used to have our own servers to host our mail, our websites, etc. Nowadays, where is your website? Maybe it's hosted somewhere on the cloud. Okay, where is your mail? Maybe you have a third-party provider, okay, that you are subscribed to, which allows you 100 or 1,000 emails or email accounts. So most of them we're putting it to, okay, other people. So what is the security implication of that? One is, and this was it's a concern earlier on. Nowadays we just trust it, right? But in the earlier stages, before we really adopted this, the main concern is, hang on, this is my data. I am now going to host my data, my mail, and everything in there into someone else's server. What does that mean? There is another proponent, another administrator behind it. They might be able to see my confidential email, right? So obviously nowadays, there are, as part of the contracts, there are things that, that they say or that they put in there to assure you that it is really protected, that they don't have access to your private information or private data. But those are real concerns. And what we're looking at here is how the security practices that we do has evolved over time as the internet also evolves. Okay, there are different ways to handle security as the internet evolves. But some things are still fundamental, such as this. The goals of information security. It's funny because the diagram, the icons have somehow disappeared. Now you may access the materials. I think I'll just post that here so that you can follow. So if you open this link, this is a PDF file of this presentation. Okay, you will see this diagram clearer. So over there, it's basically just the 3 goals. confidentiality, that's the C, integrity, that's the I, and the last one is availability. This is what we call as a CIA triad. Okay, this is basically the main goals that we try to achieve in information security. The first one, C, confidentiality, prevents unauthorized use or disclosure of information. Okay, this is usually when we talk about security, we refer to this. We want our data to be protected. Okay, it should only be read by this maybe a few set of people. It has to be confidential. And this is what confidentiality does, right? By implementing things like access lists or encryption and things like that, then you are somewhat limiting who can access that information. The next one is integrity. This one is a bit different. Your data can be exposed to the public. However, your main goal is to make sure that the information that you sent out is the same as the information that you created. Say, for example, you receive an email from your boss. Okay? The two questions there is, one, is this really coming from my boss? How do I verify? The next is the entire content. He says to do this, but is this actually the thing that he typed, that he composed? So with integrity, you are able to check the accuracy of the information and verify that the source of the information is also correct. The last one here, okay, this is A, availability. Okay, availability is about, okay, timely access to information. If you are offering a service, say you're operating an ISP, or maybe a simple website, or maybe you have an online shop, you want these services to be available to your customers all the time. So this is CIA. Again, confidentiality, integrity, and availability. And this is important for information security. Now, most of the time, you want to achieve maybe one, two, or maybe all of these goals. Okay, but you have to know which one. Okay, sometimes you just want to provide confidentiality. Sometimes you just want integrity, but you don't really care that your information is out there. Okay, sometimes you're not even concerned about confidentiality and integrity because the service that you're providing, maybe it's only for availability, right? So have a look. When we discuss the different protocols later on, please bear in mind which one among these are we trying to achieve, all right? Okay. Oh, well, all of my diagrams are gone. Okay, please refer to the slides again, the PDF file. So you'll see there on page 7, attacks on different layers. So on the left side is your OSI reference model. On the right side is your TCP IP model. Both are acceptable models of the internet infrastructure, right? Now, the reason I put that there is to show you what protocols are operating on which layer. Layer 2, you have a few there, ARP, NDP, OSPF. Layer 3, you have IP related, so IPv4, IPv6, ICMP, and things like that. Layer 4, you have TCP and UDP protocols. Layer 5 is NFS or SOCKS. And then layer 7, you have different types of applications. Actually, there's a lot of applications, not just the ones that you can find in the diagram. So with those protocols operating, there are weaknesses, of course, and folks have exploited them. So the ones in red are the attacks. You have ARP spoofing and NAC flooding on layer 2. You have ICMP flooding on layer 3. You have different types of TCP attacks, such as SYN attacks, routing attacks as well, on layer 4. And then on the top layer, we have others. So depending on the application, say you're operating a DNS server, so you can be prone to either DNS amplification or DNS cache poisoning attacks. If you're operating a website, HTTP website, right, maybe, you can be attacked with DOS or DDoS. You can be a victim to spamming and scamming. You can become a victim to phishing. Okay, if you have a SQL server as well, same thing. There are SQL injection attacks. Now, these are only a few, okay, examples of attacks. Now, I'll try to explain some of them, right? Apologies, the diagrams are missing, but I hope you're also looking at the PDF handouts that I gave you. All right, let me skip that. Let's just look at some examples of these attacks. I don't have time to cover for everything, but I skipped the first few ones at the bottom. You have there the ones that are on layer 2 and layer 3, mostly spoofing attacks, which is still really, until now, they are still very possible types of attacks. But let's skip that part and go directly to TCP. TCP is basically operating on layer 4. Okay, so we either have like TCP or UDP there, connection oriented or connection less oriented. With TCP, it utilizes what we call as three-way handshake to verify the conversation before starting to send and receive messages between each other. So the typical connection between a client and a server is like this. The client sends a SYN message, server sends a SYN ACK, and then a final acknowledgement will be sent to the server from the client. Okay, this is what we call it as a three-way handshake. Send, SYN ACK, and then ACK. After that's completed, that's the time that they can now send and receive messages to each other. However, when there is an attack, what happens is your attacker is sending a lot of SYN messages going to the server. Obviously, the server is now required to reply to all of these SYN requests. And so, if the attacker does not send the final acknowledgement, what happens? Okay, you have these open connections and they are finite. If there is a legitimate user that wants to access the same server, because we have all used up all these connections, incomplete connections, the legitimate user cannot establish any more three-way handshake with the server and cannot use its service. So what type of attack is this? Is it an attack on confidentiality, integrity, or availability? It's an attack on availability. Okay, it's a denial of service attack. Okay, and as you probably have heard on the news, those attacks are one of the simplest and one of the most common types of attacks that are being used out there. And it's not just on the TCP, right? It's not just on this layer. It can also happen on, say, even the on the layer 7. Okay, even on your application layer, or even on the lower layers, layer 2 and layer 3 as well. You have ICMP attacks and things like that. Okay, now next example of an attack is DNS Cache Poisoning. Now, if you're familiar with how DNS works, right, you go to a DNS server. So your client goes to a DNS server and it do a query, a recursive query to the DNS hierarchy until it finds the answer. So it's a bit like this. Your DNS caching server or recursive server will send a query going to the root, and then it will go through recursion until it finds this name server, which is the authoritative name server, and it will reply with the answer. So saying that, hey, this is the answer you're looking for, this is the IP address of this. And then it will reply and it will be sent to the client. Now, this server is sending a lot of these queries out because you don't only have one client, right? You will have a lot of clients. So it will send many queries with different query IDs. The problem with earlier implementations of DNS query is that it uses query IDs that are sequential, meaning if my query ID now is 64571, the next will be 64572, 64573, and so on. And so if I have an attacker sitting here, he can just, try a range of query IDs in the hope that one of them will match. So it sends a reply with multiple replies with different query IDs, and then hoping that one of them will match like this. If it matches, this answer will be sent to the client. This client will now connect to the wrong or fake web server and then provide his information, maybe provide his username and password, his credit card details, and that's it. Okay, so that's DNS Cache Poisoning attack. Now, what makes this worse is, say for example, this server is an open resolver. And as you can see, by default, a DNS is an open resolver, right? The moment that you implement it, it's open, meaning it answers questions from everyone. So if you deploy an open resolver, you're open to the internet. Okay, anyone can ask you a question. So what can happen there is this attacker can send the query, okay, to this resolver so that he now holds the query ID. So he can trim it down. So you can see that this is more of a targeted attack in such cases. Okay, so that can be sure that the response will arrive. This is an example of cache poisoning. And how can we address this? How do you think? What type of attack is this? Integrity, right? It's kind of like an attack on integrity because you are now receiving fake information and there's no way for this server nor this client to verify that it is coming from the right source. It should be coming from the authoritative name server. Right? Hopefully that's clear, everyone. I think I have a few more. Where is it? Okay, I don't have any other attack examples here, but those two should be sufficient, should be big ones. Now, let's look at some ways that we can implement security. The first one, okay, is a concept of trusted networks. So before, our concept of protecting our network, because it's mostly small networks, say LAN type in that day, okay, mostly our enemies are outside. Our enemies are beyond our network, okay, coming from the internet. So how do we protect our network is through standard defensive-oriented technologies. We set up firewalls, okay, around our system. And then as a second line of defense, we can also implement intrusion detection systems, IDS or even IPS, intrusion prevention system. So these are intelligent systems that has the capability of telling you that there is a possible breach. Okay, by looking at signatures that are mostly pre-populated on the system, they're able to see that these types of packets that are coming in are mostly similar to, some of these signatures, and then this can be a possible attack. Through setting up firewalls and IDS, you can prevent most of the attacks that are coming from outside. Okay, so they are important. We should still implement firewalls and IDS. However, is that enough? Now, the thing with security is you can only be as secure as your weakest spot, right? You have to provide all sorts of protection, but the moment that there is some loophole, a very tiny loophole, the attacker can take advantage of that. So what we're saying here is you can have those, but if there's like one machine, a legacy server that is, maybe it has some open ports, and for some reason you have not patched the system for quite a while because it's legacy, then an attacker saw that and then was able to infiltrate that system. Now from this point on, the attack will be coming from inside, coming from this victim machine, and then it will be inside. So in that case, if you don't have enough protection inside, that will also be a big problem. So what you need is to also build trust on top of the TCP/IP infrastructure by setting up things like strong authentication and public key infrastructure. Strong authentication is a must, even for, say, your local machines or for your online accounts. Make sure that you have very strong passwords. So we still use that. We still use usernames and passwords. However, make sure that you provide very strong passwords, and if you can, implement two-factor or multi-factor authentication. What is that? So in authentication, right, what we normally provide is information that we know. However, with two-factor or multi-factor authentication, you must provide at least two kinds of identification. Usually something that you know and something that you have. Think about an ATM machine. If you're going to withdraw money, okay, you have to provide the card, okay, insert into the slot, and then you have to input the PIN. So in other systems, it's a bit like that. You have to still log in using your username and password, and the next time it will ask you for a token. Either you provide something, maybe it's a random value that is generated by your random generator, okay? Or it can be other things like scans, bioscans, fingerprints, and things like that. So those are different forms of authentication, and if you have more of those, the better. Okay, but you don't want to overwhelm your users as well, so it should be something that is still manageable. Another one is the use of public key infrastructure. Now, if you're offering services to your customers or to the internet, how do you verify that it's the right, service? Say, for example, you're accessing your bank website. How do you make sure that this is really your bank website and no one is just pretending to look like your bank's website? That's through the use of digital signature. Okay? And through public infrastructure, you have that hierarchy that vouches or that signs these signatures, and then we use that on those websites. That can be used in that sense. You can also use PKI, say inside your network. Say to access certain resources, you must have certificates. To access your company website, you must have certificate. Okay? To access your file server or whatever shared data, or maybe using your Wi-Fi. Maybe that will also be a requirement. You must have a certificate. So that's all part of the public key infrastructure, right? And through that, you can set up strong authentication and building trust inside your network. We've already talked about this, strong authentication, right? Two-factor authentication by presenting passwords and tokens. And this is an example of a two-factor authentication. You have OTP, one-time password. Now, if you're not using two-factor authentication yet, for most of your website, web access, say you have accounts online, Google, Facebook, Twitter, GitHub, and all of those things, make sure that you enable two-factor authentication. You will most likely need, okay, a random token generator, a password generator, okay, and it presents you with a 6-number code that is valid for 1 minute, I think. So when you log in, you still provide your username and password, and then after that, you have to provide this token to the system before it accepts your login. Okay, multi-factor or two-factor authentication. Next one is the concept of authorization. So this one is about who is, well, not just who's allowed access to the system, but what can they do once they're in the system. So first, you authenticate yourself. After that, you're authorized to do something, right? So they mostly go in pairs. Now, what should we do with regards to authorization? We must have a system in place to only authorize certain people. There are different concepts in security that revolves around this. The principle of least privilege, meaning when you have like a new account, maybe a new person in the company, you don't just give them access to everything. Okay? It should be least privilege, and then it develops in time depending on what they need to access. Okay? There are other concepts here, but basically one thing that you can implement to do this is by having different levels of access criteria, different levels of trust. You assign roles to people, you assign them into different groups. Maybe depending on location and time, you can also limit access. Say, for example, if your users normally just access the system during office hours, so you limit it. This is only available within this time period and for people that are coming from this location. Okay, another one is transaction type. Are they able to, maybe exfiltrate data from your system at certain periods of time, or maybe for certain accounts or not? Maybe they're only allowed read access, not write access, things like that. Okay, so authentication and authorization usually comes together. First, you authenticate first using the authentication mechanism, and then you'll have access to the service. This service, before allowing you anything on the system, will go to the authorization mechanism, checking whether for this username, for this client, what are the services or what parts of the system is he allowed to do. Okay, normally you see this implemented as a single system. So you say you have AAA or Radius or LDAP and things like that. Okay, but the idea of authorization and authentication are two separate things. Now for access control, AAA is a very important concept. That's authentication, authorization, and accountability. So we've already kind of discussed the first two. Authentication is who is allowed in the system. Authorization is who is allowed to use this particular service and what can they do in the system. And accountability is what they've actually done. This one is all about logging. Okay, so you should have logs of everything that is being done on your system. Why? This is for non-repudiation. So for example, a particular user logged in at 1 a.m. in your system and then deleted several files. Okay, the next day, the manager is looking, say, what happened to these files? They're all missing. What can you do? You can search the logs. And then because you have non-repudiation, because you have logs, you can identify to which user is this action attributed to. By doing so, you are now, you're now like implementing, you're now showing that this user cannot repudiate or cannot deny that they completed or that they did this particular action in the system. Okay, they might have legal bindings as well in some cases. Any questions so far? So AAA, okay, authorization, authentication, and accountability are important things, as well as two-factor authentication, okay, public key infrastructure and things like that. Now let's look at a very important concept in security, which is crypto. Okay, everything relies on crypto. Cryptography is actually older than internet itself or security itself. If it's been used for many years before that with different systems during the Industrial Revolution, even way before that. But it has found a good niche in the internet, in security particularly. So cryptography deals with creating documents that you can share publicly, okay, but still providing confidentiality to it. So if I want to send something over the internet, if I only want it to be read by certain people, I can encrypt it. I can use crypto, okay, so that I can share this secretly. Two other terms that are related to cryptography is cryptanalysis and cryptology. Cryptanalysis is the other way around. In cryptography, you have plain text, and then you do crypto so that your output is undecipherable. With cryptanalysis, you have this undecipherable message, and then you don't have the key, but you want to find the plain text out of that. So it's reverse engineering. And then cryptology is a combination of both. It's the entire study, okay, combination of cryptography and cryptanalysis. So cryptography is a function of these terms, okay, plain text, cryptographic key, and then ciphertext. There should be a diagram here. It's not showing as well. You can check the slides for that. But essentially, what we're showing there is like this. You have your plain text, okay, you have your algorithm, and then the output is like this, a ciphertext, something that is undecipherable. This is the entire function that we are looking at there. There are functions of plain text, encryption key, and then algorithm to come up with your ciphertext. Encryption algorithms in modern crypto are all public. Okay? If you look at way before modern cryptography, okay, such as ciphers, say Vigenère cipher or Caesar cipher, it's a bit different because you should keep the algorithm itself as private. But the problem is it's not always easy and it takes time to come up with the algorithm. The easier way is to keep the key safe, but let the algorithm be public, right? So in the way, you're still protecting this because they're both required. So you use the algorithm, you use the encryption key to come up with this. The algorithm is public, the key should be private. Okay? So meaning you can use the same algorithm, you can always just change the encryption key. Now when decrypting, when using the doing the other way around, you have your ciphertext, you decrypt it with the same algorithm to come up with a plain text. This is on the recipient side. They can use a decryption key to be able to do that. So this is the concept of encryption and decryption. You encrypt your data using an algorithm with a particular set of encryption keys to come up with a ciphertext. And then after that, on the recipient side, okay, it will be turned back into the original data using a decryption key. Right? Now, what are the keys that we're talking about? Now, crypto, or these types of encryption, can be largely categorized into two. One is symmetric algorithm, symmetric encryption, wherein the encryption key and the decryption key are the same. So we call it as shared key. So when we say symmetric key algorithm, we also call it as shared key algorithm, secret key algorithm, because the key that you use to encrypt is the same key that you use to decrypt. Same. So what's the implication of that? These two parties, the sender and the receiver, must share the same key. How are you going to do that? It's done out of PAN. You can maybe send it using, a secure protocol. Maybe you hand it over using a, secure USB stick or something like that. But it's really done out of PAN. But the essential idea here is you should know, okay, for both parties, you should know the shared key. And this key must be kept private all the time. It should only be between these two parties, right? To provide confidentiality. Next is asymmetric encryption. What's the difference here? You have an encryption key, you have a decryption key. Same concept, however, you now have two sets of key. One is public, another one is private. So they are generated at the same time, they are related to each other, but the private key should be kept private all the time, okay, as the name implies, and the public key should be shared. So what's the difference here? You don't have to, okay, do the exchange of the secret key between your sender and receiver all the time, because you have the public key. So you can encrypt the message using the private key and decrypt it with the public key. Or you can encrypt the message using the public key and decrypt it with the private key. So they go in pairs. You encrypted one, you decrypt with the other. Okay? Pretty straightforward, right? So you just need two sets, two keys, public and private key. For this, you use one to encrypt, you use the other to decrypt. Now you might ask, what is the implication of that? If someone has a hold of my public key, can I then find your private key? The answer is no. Right now, it's not feasible to be able to do reverse engineering and find out your private key given the public key. However, they are related to each other because they generated together. Right? Does that make sense? So that's asymmetric encryption. Another one to look at, as I've said, is public key infrastructure. PKI is somewhat of a complex set of different standards, different protocols as well, and different elements that makes up the infrastructure. And by doing this, or by having this, we can provide either confidentiality, or we can provide integrity or authentication, by using PKI. The core of a PKI is a digital certificate. What is this? A digital certificate, you may say, is it's a signed digital object. Okay? that represents a person or company, okay, or an entity. It provides information about that entity, say maybe the company name, the address, basically everything about it, okay, and his public key. Okay, now this usually should be enough for typical exchange. Like think about asymmetric algorithm, right? But if I am a website and I want someone to verify that this is my website, I can always have a public key and I can always generate a certificate for this, right? But if I upload, say, a public key, how do I know that this is still the right company? There's no assurance. So this is where certificate authorities will come in, CA. The CA will vouch for that entity that he is really that particular person that he's claiming to be. Okay, so he will sign that and then he will sign the public key and then give that digital certificate for this entity to publish. At the same time, this certificate authority has a repository that lists, okay, or includes all the certificates basically that it has issued and it has revoked. So that's the idea behind PKI. If you have a publicly facing service, website or something like that, make sure that you implement PKI. So aside from the CA, you can also have a registration authority. This is usually for big CAs. So an RA is the one that verifies the identity of the applicant. Before issuing a certificate to that, they should verify this. Then they maintain a repository, they maintain an archive of all the old and revoked certificates. Now we're back to the slide. You have seen this. Okay, again, some of the diagrams are missing here. But what I want to show in here is how you have these many different attacks. Okay, we've discussed some of them, but what are we doing to protect them? The answer is, of course, this is not part of the main TCP/IP protocol, but later on there were protocols that were, published. Okay, there were protocols that were implemented to address those issues. 802.1x is an example on layer 2. Okay, you have IPsec for layer 3. You can have things like TLS and SL for layer 4, sometimes even for higher layers. And for layer 7, you have DNSSEC, PGP, SMIME, HTTPS, and a few other things. Most of the layer 7 protocols rely on lower layer protocols, particularly TLS, to provide protection. So you are encrypting the entire session. Okay, so that means in a way, okay, you don't have to implement any more particular security protocol that is only used by DNS or by POP or by IMAP. Okay, they use TLS on top of that, okay, to provide that form of protection. Okay, now I don't have information about all the other protocols here. Usually on a big class when I'm doing a workshop, I can show you each of them and explain to you how they work. But here, due to time limitations, we'll just cover a few. So one is VPN. How many uses VPN and what is a VPN? The idea behind VPN is to have, as its name implies, a virtual private network. You are passing through a public network such as the internet. However, you still have that private network because of encryption, because of encapsulation. It's like you have a tunnel between two parties or two networks or even two devices. Okay? And all the message that you send through the public network is protected because they're going through the tunnel. That's the idea behind it, right? There are two main types of VPN. Okay? Remote access VPN and site-to-site VPN. Remote access VPNs are usually done when you, say, are working remotely and you want to access your office network. Okay, so you have a client installed on your machine that connects to your VPN machine. The other one is site-to-site VPN. So you have VPN between two static networks. Okay, you implement or configure these either VPN devices or routers, okay, so that they will set up VPN with each other. This is also what we call as router-to-router network. Remote access VPN is usually the client to router, client to firewall VPNs. There are different VPN protocols: PPTP, L2F, L2TP. Okay, PPTP is the one developed by Microsoft. L2F is developed by Cisco, but the IETF standard, which is mainly based on those two, is what we call as L2TP. These are implemented on layer 2. So most of the VPN protocols are actually done on layer 2. Okay, so if you look at these three protocols, that's all layer 2. However, there's one other VPN protocol, and it's kind of like become standard nowadays. It's implemented on layer 3. We call it as IPsec. Okay, this is the open standard for VPN implementation, and as opposed to this first three, IPsec operates on layer 3, on the network layer. So it looks a little bit like this. You have different machines connecting to each other. You don't really have to worry about setting up VPN directly from the source to the destination in this case, because VPN is set up in these two routers. Okay, so it's site-to-site VPN, and only in the network layer. So if you have different applications here, okay, they're actually mostly not aware that there is IPsec implemented here. Okay, so they're independent of this. So that's one of the advantages of having IPsec. Okay, most of the applications that you implement here, whether they're already secure by themselves or not, you have this added protection of IPsec once it goes to layer 3. Okay? So let's talk a little bit about IPsec. Over time, I've had so many people asking or interested about this. Okay? It's become, as I've said, a standard, so many of the networks want to implement them. And particularly if you have routers that have support for IPsec, it's actually quite easy to do. Now, the thing, the hard part with IPsec is understanding the concept itself, because you have so many components and so many interactions between them that are happening, and the concept itself and the RFCs are quite hard to understand. So let's look at IPsec by looking at these components and understanding them, right? You have these components: security associations or SA. You have authentication headers or AH. You have encapsulation security payload or ESP, and you have internet key exchange. You also actually have eSEC01, so sometimes you don't include that in the components, but basically it's a key management protocol because you're exchanging a lot of keys. Remember the concept of crypto, right? IPsec is kind of like an implementation of that. Okay, you'll be using symmetric key algorithms, you'll be using asymmetric key algorithms, and you're not only going to use one set. Usually they have lifetimes, and they would agree on certain, characteristics, I guess, of the encryption that is, or the tunnel being created between the two, and then there is a lifetime where you will have to recreate or generate new sets of keys. Okay, so that's how it can become complicated. So basically, with this, security association is just the information about the encryption algorithm to use, the key lifetimes, the Diffie-Hellman group that will be used for integrity checks, or for basically for hashing what algorithms we're going to use. So basically, one system has that, and another system, before you agree to send messages with each other, you have to negotiate which protocols we're going to use. So those information are added in the security associations. Okay, once they come up with that, then they can now start establishing. IPsec has two main, say when you talk about IKE, you have two main phases, phase 1 and phase 2. Phase 1 is the kiss account phase, phase 2 is the IPsec phase. So you're actually creating a tunnel, basically a secure channel first, and then within that, you're creating an IPsec tunnel. So that's the extra protection there. But you're going through the same kinds of negotiations and process and exchange of keys between the two parties for establishing both channels on those two phases. Now, AH and ESP are the security protocols. Okay, you either can choose AH or ESP, or you can use both. AH is usually just for authentication. ESP has an added encryption. Okay, so there are few differences between the implementation of both as well, but the main difference between them is if you want to have confidentiality, you use ESP. However, in many cases, they use both. They take advantage of the confidentiality of ESP, but they say when it comes to authentication, AH is a little better, so you can actually use both. Okay, but this is if you're implementing what we call as IKE version 1, okay, which is the actual exchange and negotiation between the two VPN endpoints. Okay, so there's still a lot of things to understand about IPsec, but just to show you that this is one of the most important protocols that you can implement on layer 3. IPsec was originally created to be part of IPv6, okay, but not everyone is using just IPv6 at this point, so they had to port out an IPsec protocol that can be implemented in v4. So if you have IPv4 network, okay, on your layer 3, you probably should consider implementing IPsec, right? Particularly for setting VPN tunnels for site-to-site. Another protocol is for layer 4, TLS. Now, most of us will be familiar with this, maybe not in the operational context, but mostly on, familiarity because we use it. Most of us access websites and it uses HTTPS. HTTPS is probably the most common protocol. Well, HTTP and HTTPS, but for secure protocols, HTTPS probably is the most common. It's essentially HTTP plus TLS. So it still for security, it's relying on TLS. Transport layer security. Most of you will be familiar with this as SSL, Secure Socket Layer, because TLS is a standard, but it's based on SSL version 3. Okay, the current standard now and the one that's being maintained and updated is TLS. That's the IETF standard. Okay, Secure Shell or SSH, mostly if you want to connect to servers, to your routers, to your network devices, okay, the way or the secure way to do this is to use SSH. Most of us still use Telnet, and there's nothing wrong with Telnet, except that you're running into a risk that someone might be eavesdropping and they can read all of the messages that are being sent between you and the remote network that you're connecting to. So whenever you can, especially if you're in a private network, use SSH in replacement of Telnet or even RSH. Not many people use RSH anymore, but most of us still use Telnet quite a lot. Right? So those are some of the security protocols. Obviously, I cannot discuss all of them, but you've seen in the diagram, okay, that you have them as a sort of protection. Now, why did I show you these things as a layered approach? That's because we've established that security relies on protecting all of them. Okay, so if you have provided enough protection in your layer 3, but you haven't provided enough protection in other layers, that can still be a possible vulnerability to your network, and someone might exploit it. Okay, so just to wrap up this session, security management is an important thing. Security management relies on having the right policy, communicating it with the right people, and having guidelines, standards and guidelines to implement it. There is always a possibility that you will be attacked. Okay, some of the popular ones, it's kind of expected that they will be attacked with DDoS or other related types of attacks. But for small ones, some of them are quite confident that, yeah, no, it's not going to happen to me. But the time that we are complacent like that is the time that we get attacked. So we must implement security management. We must implement security policies as much as we can. And if there is a chance that we can be subjected to these attacks, we must have a disaster recovery and attack mitigation plan in place. So that's why you should have a security policy. Okay, you should also do risk assessment. Okay, so that you know what are the possible risks on your system, what are your assets, okay, and what are the possible exploits that can be done over those assets. How can you protect those assets? Okay, so by doing risk assessment, you can gauge all of that. Which ones are my most important assets? Okay, then I will put most of my resources there. If I have others that are not so important, what can I do to limit or mitigate the possible exploits that can happen there? Okay, so looking at risks, threats, okay, exploits, and vulnerabilities. You must develop a comprehensive security policy. Big question. In your organization, do you have a security policy? Is it a written security policy? Most of us, we have some sort of understanding among us that, yeah, this is what we should do, but it's not written on paper. It's always good to write it on paper, to document it, so that you can always refer to that document. Now, you must revisit this document at maybe every year or every couple of years, okay, just to make sure that it's still updated and that it still represents your security policy or your security plan. Some ideas that we have here, okay, say for example for an enterprise network, for users, you must have a minimum password length. Of course, you should encourage your users to change their passwords frequently, maybe every 3 months or so. You must have an access list or ACL. Who can access these devices who are not allowed? Again, the concept of least privilege. Okay, there's also the concept of zero access first, and then it adds up again. That's similar to the least privilege policy. User creation and deletion process. When do you create users? When there are new users, of course, but when do you delete them? Okay, do you outright delete users that are no longer in your system, or just forget it? You should always encrypt your data. Okay, usually even just for internal network, it's always a good idea to encrypt. Most of us encrypt our data while it is at rest. What's the difference? Data at rest is a stored data. But most of the attacks, okay, say that those that are eavesdropping the network, they exfiltrate data by eavesdropping, meaning they're listening on the wire. So if you're transferring data between two devices, that's when they grab this information. So encryption is not only for data at rest. You can only provide encryption for data that is in use or in motion. Okay, so encryption is a very important thing. If you can, try to use digital certificates as much as you can. Now, the problem with not being prepared, maybe we don't have a disaster recovery plan, is what are we going to do when it actually happens? Most of the time, we panic, which is normal. But if we have this attack mitigation plan, we have steps that we can follow. Who are the responsible people? Where are the tools that I can use? What is my first step? Okay, if it doesn't work, what is my second step? Who is going to talk to the users? Okay, who will make the final decision? Those are the things that should be documented in your attack mitigation plan. Okay, there's still so many things to understand about this, but one last thing that I just want to quickly discuss is the APNIC quiz database. What is this? Most of you might have used this for tracking some information, say looking for, hey, who owns this IP address? Which network is it coming from? If you are a victim of, say, massive denial of service attack coming from a single IP address, you will want to use the APNIC quiz database to look for the person to reach out to, to troubleshoot what's going on. Is this a real attack? Or is this unintentional? If you're getting a lot of spam coming from these networks, you might also want to check the quiz database for such information about IP addresses, the contacts that you can use to know and understand things. As part of the LIS database, there's also what we call as a routing registry. And normally, okay, networks refer to the routing registry and create their policies implemented on their routers to know which prefixes are allowed, where they're coming from, okay, which AS numbers for these IP addresses should be allowed in my system. That's also quite useful. And one other thing is the IRT object. If you are an APNIC member, meaning you have resources or you have IP addresses, okay, make sure that you update it with the correct IRT contact. What is that? IRT is incident response team. If there is an attack or breach or anything untoward that is related to that IP, okay, you have that dedicated team that can be contacted. So that also means if you provide an email address or a contact number on the IRT contact, make sure that it is always being manned. Okay, someone is looking after this number or this email address. Okay, and monitor whether there are incoming reports for your IP. Because there's always possibilities like you own this IP address, but someone has spoofed your IP address, okay, to implement a massive attack. Another is the attack is actually coming from your network and you don't have an idea about it. Why? Because an attacker was able to exploit your email, say maybe your mail server, and send a lot of spam coming from that mail server. Okay, so this is all about coordination between network operators that can help all of you to troubleshoot any network issues. Okay, to look at different security, issues as well, and find where they're coming from. So whenever you can, make sure to update the WHOIS database with the correct information about yourself and your records. Alright, so that is the end of this presentation. Do you have any questions? This is network security fundamentals, right? So it's basically understanding the concept. So we discussed quite a lot of terminologies here. This is not all. There's still quite a lot that you might want to look up. Okay, and from this foundational topics, okay, if you look at certain types of, say, security boxes or security protocols, you can identify them with the fundamental topics that we have covered today, okay, and identify whether this is what you need to protect your network, right? So I don't see any activity on the chat panel, so I reckon most of you don't have any questions. Just last one from me, if you can click on the survey for me, please, and fill that in, I'll be very happy. So I'll also write that down on the chat so that you can have a look at it, or maybe it will be easier for you to click there. Okay, can't see the link. There seems to be an issue with the link, so yeah, try this link, but if you can, that's okay. The question there is, when is your next session? We generally don't do the network security fundamental session very often because it's such a it's a fundamental topic. So what you can do, I don't have the list of the courses here with me, but you can check it out on our training website. It's training.apnic.net/events. Actually, I can open it up as well. Let me just quickly do that. So training.apnic.net, under events. So this is the link that you should go to. Let me just see if there's network security soon. The next one is in, I think, no, not until February. But another way is I don't think I'll be able to upload this recording anytime soon, but you can go to the APNIC training YouTube channel. I'll get you a link. And this one here. That one. So this is a recording from previously. That was in 2015. I don't have one from 2016 because we stopped doing it regularly from last year. So you can check that out and watch from there. But thank you for the question, Arnell, and thank you for joining us, however late it is. Now, any other questions or comments from the class? If not, I won't hold you back. Thank you very much for joining us today, and I hope that you learned something. We have a lot more security-related topics that we can you can register and share with you.